Delmy says, "Hi, you're welcome back to I know the question on geometry." Now, this is an interesting question. Uh, in order to solve this, we first have to join this point here to the point here. So we create a diagonal for this so we can easily solve. So we have an imaginary line here like this. Good. So when we create this, we end up forming a similarity between the first triangle here and the second triangle down here. Or in other way, what we can do is to join this here, join this point here to this vertex here. So we have something like this. Good. So we end up getting a triangle from here. So we can make, let's name this A, and I name here B and C. So in short, we'll have a triangle of this sort. Understand? So we have this. So we have A, B, and C. So the idea here is to get the diagonal. So when we get the length of the diagonal, that is A to C, we will be able to find the area of the square. Remember, the square of the length here is x, then the other length also be s. Okay, so in short, so since we already know that this is a right angle triangle, okay, so we can use the Pythagoras theorem to solve for the hypotenuse here. Okay, so the longest length, that is AB. Okay, so that will be 5 when you solve. Okay, so that means from here to here is 5. Okay, so remember that here we already have a division like this. Okay, so and we know that the angle here is a 90 degrees. So we have 90 degrees here. So we just have to find the angle here. Okay, so using this angle, that will help us to get the length from here to this side. So that means we'll be using the sine rule or the cosine rule to find the length, this length here, A to C. This is already known. Okay, this is already known. That is the B to C from which is here. So which is 2. Okay, so you just have to find this area here. You just have to find this angle here. Okay, then use the 90 degrees, then use that to find the length here, the longer length here. So cosine rule will work. Now in order for you to find the angle here, you may use the SOHCAHTOA approach. So since here is already 4, you know this side to be 4. Okay, and you know this length here to be 3. So that means you just use the SOHCAHTOA approach. Okay, so the tangent ratio to solve for this side here, to solve for this angle here. Okay, so if let's say this is theta, so we'll be having tan of theta equals the opposite on adjacent. So we have 4 4 on 3. Okay, so that means we have in theta equals tan inverse of 4 on 3, which should be equals to the tan inverse of 4 on 3, which should be equals to 53.13. So that means the angle will be 53.13 degrees. Okay, so that can be added to the 90, so you get the total angle here. So that will be, so it means that angle ABC will be equals to 90 degrees plus 53.13 degrees equals 143.13 degrees. Okay, so we can use the cosine rule to solve for our length AC. So that will be length AC. So means that we have AC square. You can use the formula AC square 5 square plus 2 square minus 2 twice the product of the two lengths cos the angle, so which is 143.13 degrees. So this will be 25 4 29. So AC square equals 29 minus this here, so 10 20, so 20 cos 143.13 degrees. So in solving, simplifying all, we have 20 cos 143.13. So that should be negative okay, so that should be a negative. So you have AC square equals 29 okay plus 15.9999, so it's 16, so we can make it 16. Okay, so this should be equals to 45. Yeah, so AC should be equals to square root of that, so square root of 45. Now you should note that x here, okay, this is also a rectangle triangle, so we can pick A, C, and the origin here. So that will be a rectangle triangle, so that means that we can pick it out and have something like this. So this will be x, and we know this to be root 45. So this means that x square plus x square equals, by Pythagoras theorem, should be equals to this hypotenuse. So we have square root of 45 all square. So when we simplify this, we get 2y of x square equals 45. Okay, so x square equals 45 on 2. And you should know that the area of the